Hello everyone, welcome to chemistry class. This is the part 5 of this chapter number 3 and the second video of the day. In the morning today itself we have seen the part 4 and we have learned about the methods of preparation, the physical properties, the chemical properties of bases, and at the end of that video we have also learned about the uses of different bases. Now the important topic that comes here now we will learn about it is how we can identify or how we can test for different acids and base, and we can get to know about the extent of acidity and bases in different chemicals or different substances. We have already been learning about the indicators. Indicators are the complex compounds or complex chemicals which are used to identify acids and base. They can be litmus, or it can be methyl orange, or it can be phenolphthalein. By the color change that is shown by these indicators, we can identify a chemical or a substance's acid or base. But if we have to identify the extent of acidity, if we have to compare two acids for example, then how we will do so? If we have to compare two bases, which is more basic, which is less basic, for that we are having a scale that is known as the pH scale. So what is the pH scale we will be learning now. So first of all, before beginning the topic, we will understand the meaning of the term pH. This pH scale was given by a Danish person. He was a scientist. His name is Sorensen. Sorensen gave the pH scale. The meaning of the pH, in this P and H, it can be broken up into two parts. P is actually a German word that is potens. Potens in English language, it means as power. So it is the power, and H means what? It is hydrogen. So power of hydrogen is actually what is called as pH. So we are measuring what? We are measuring in pH the extent of hydrogen ions which are present in a particular solution. How many hydrogen ions are there in a solution? Based on that we will decide the level of acidity or the basicity in a particular chemical or substance. Let us understand here in more details how it is done, how we can calculate this ions here. For that we will make it more clear. Now we are taking a particular solution, and solution contains water, or we can say this water ionizes into two different ions. Water is H2O, and it ionizes and forms what? It forms H plus, that is hydrogen ions are formed, and also it forms OH negative, that is hydroxide ions. This type of ions are released, they are produced when water molecule breaks down or dissociate into different ions. Now each of these ions are having their own concentration. The concentration value is determined in the numerical terms, and it is given up here, that is 1 into 10 to the power minus 7, and this is the unit for it, moles per liter. So 1 we can neglect because in the product it will be cancelled. So we can say the concentration of H plus ion is what? The concentration of H plus ion is equal to 10 to the power minus 7 moles per liter. Similarly, we can also say that the concentration of the OH negative ion, that is how much? That is also 10 to the power moles per liter. Concentration of H plus is 10 to the power minus 7. Similarly, of OH minus also is 10 to the power minus 7. Now if we have to calculate the ionic product of water, then what is this ionic product? Ionic product is equal to of the concentration of H plus and the concentration of OH minus. We can write it as follows. This ionic product is denoted by Kw, that is the symbol that is used. We will understand this here, that is calculated by the product of H plus and OH minus. So what we will do, we will just multiply this. The value of H plus was, what was it? That was 10 to the power minus 7 for concentration of H plus ion. Similarly, the concentration of OH negative is how much? It is also 10 to the power minus 7. So if we take the product of this, both of these values, then what we will get? We will get the value is equal to 10 to the power minus 14, or in other terms we can also say it is 1 into 10 raised to the power minus 14 mole square per liter square, because product we are doing now, so the units also will be changed accordingly. So here what is given is the ionic product of water. Now if we are adding acid to water, acid contains what? Acid contains hydrogen ions, H plus, or we can say in other words hydronium ions are there. So if in water we are adding acid, then what will happen? That water will become acidic in nature. The acidic nature will increase. And if acidic nature is increasing, that is coming because of what? It is coming because of the increase in this number of ion, that is H3O plus ion is increasing. In simple words we can say H plus is increasing and if H plus is increasing in that solution, what will decrease is actually OH negative. That means what? If positive ion is increasing, that is acidity is increasing, then negative ion will decrease. So if any solution contains more hydrogen ions, then we can say it is more acidic. That is what is done in the pH. pH is calculating the extent of acidity on this basis only. If any solution is having more H plus ion, then it means it is more acidic. If it is having less H plus ion, that means it is less acidic. The same thing is happening in the base also. With the same water only, if we are adding any alkali, that is if we are adding for example NaOH, that is an alkali, so it will release what? This NaOH will dissociate into two parts. One is Na plus and second part is OH minus. So that means that water will be provided by what? It will be provided by OH negative, and then what will happen? OH negative will increase. So if alkali is added to water, then what will happen? OH negative will increase, and its opposite, that is hydrogen concentration, will decrease. That is what is happening here. Now hydrogen concentration is less. So when we check any base solution on the pH scale, the pH scale will find out that hydrogen concentration is very less, and it will indicate us that the particular solution is actually a base. So based on the hydrogen concentration only it is done. So at the end of this discussion, we can say what? That pH scale is calculating what? The concentration of hydrogen ion. If hydrogen concentration is more, then the substance is what? It is acid. If hydrogen concentration is less, then we can say the substance is base. This is what is done in the calculation of acidity on the pH scale. This I have already told you. Sorensen is the person. He was a Danish biochemist, and he devised the pH scale. And what it is representing, just now we have seen, it represents the concentration of hydronium ions in a given aqueous solution. Yes, aqueous should be there. We cannot do it with the dry chemical only. The particular chemical has to be dissolved in water, only then we can check the pH value of any substance. So aqueous solution is compulsory. The term we have already known this. P means potence, that is power, and H is representing hydrogen. So pH is power of hydrogen. Now comes the definition here. If in the definition form we have to write this, how we can write this? You have to remember this pH of the solution is what? It is the negative logarithm to the base 10 of hydrogen ion concentration expressed in moles per liter, that is the unit. So it is the negative log of the base of 10 of hydrogen ion concentration. How it is so? Let us understand here. This derivation you have to remember. This mathematical relation also you have to remember. So here we have the mathematical relation here. pH equal to log base 10 1 upon H plus. Now when this H plus is here, it is given in denominator. When it come upwards, then you can see here, as it come upwards in the second step, you can see here a negative sign appear. So that is the definition of pH, that is negative log base 10 of the concentration of hydrogen ion. So you will remember this mathematical relation of pH here that is given, and this can be used to calculate the pH based on the value of concentration of hydrogen ion. Here we have an example that will show us how to calculate the value of pH. This can be asked in exam as well. So here you can learn how to calculate the value of pH. First, in the question what they can give us the value of H plus ion, and if we here already the pH is written, but if it is asked, then how we will find? We will write the relation that is of pH equal to log base 10 1 upon H plus concentration. In place of this H plus ion concentration, we will write the value that is given in the question. So we have written that log base 10 1 upon, and in place of H plus it is 10 to the power minus 12 as it is given in the question. Now when this 10 to the power minus 12, it will move from the denominator to upwards, then this negative value of this minus 12, it will be removed. So in the next step you can see it is coming as pH equal to 10 log base 10 to the power minus 12. Now in log we are having a rule, that is if we are given like this, if it is written log base 10 x to the power y, so whatever exponent is there, like here y is there, this y will move forward in the multiplication sign. So next step will be like y log base 10 x. So similarly here you can see the exponent is 12, this 12 will move forward in the multiplication sign. What we get as a result of that is 12 log base 10 10. Now another rule we have for the log, that is if we are getting this term here, that is log base 10 10, then its value will be given as 1, that is equal to 1. So in place of this we can replace it by 1. So we can say 12, and in this place what is coming? 1. So 12 into 1, the value comes as 12. That is the pH value we have calculated. So this is how we can calculate. If it is coming in calculation form, if it is coming for more marks, that is how you have to calculate. But simply if it is asked for one marks. For example, question is coming, concentration is given 10 to the power minus 12. So whatever value is there, minus 12 is there. So directly you can write the pH is 12. That is for 1 mark question. But if it is being asked in details, then you have to show the full derivation. Now we will move on further. After the calculation part, we will now move on how this pH scale is devised. The pH scale is ranging from 0 to 14. If the value is coming to be 7 in this pH scale, if the value is coming to be 7 for any substance, then that substance is neither acidic nor it is basic. It is a neutral substance. If it is below 7, the values below 7 here, they all are acids. The values more than 7, that is up to 14, they all are bases. And if we have to compare among the bases, then how? As the value is increasing from 8, 9 and up to 14, so 14th one, the number 14 pH is showing what? It is showing most basic substance. Similarly, or in other words, we can also say that most basic is what? It is a strong basic, or we can say it is a strong alkali, like NaOH is having the pH 14. Similarly, 0 is showing us what? It is the most acidic substance. Most acidic substance, that are strong acids, they are having the value 0, 1 and nearby. Similarly, if any substance is having the value close to 7, that is 6.9, 6.8, close to 7, then we can say they are acidic, but still they are what? They all are weak acids. They are weak acids. And if the value is just close to 7 but more than 7, like 7.1, 7.2, then what we will say? Then those substances are weak, or we can say weak or mild bases. So these are weak bases. The 14th one are strong bases. Similarly, the acids also we have seen. So this is how the pH scale shows the numbers. Different numbers are there, and these different numbers indicate the acidic and the basic nature as well as the neutral nature of any substance. For finding out the pH of the different substances, acid or base, what we are using is called as universal indicator. It is a special kind of indicator that is actually a mixture of different indicator dyes, and it will give us a variation of colors. Different colors are shown by this indicator. By that we can identify the acidic and the basic nature of any substance or a solution. So what are the colors that are given? That are based on the Vibgyor pattern of the rainbow. Vibgyor, you have to remember, that is, if the universal indicator gives us the green color, then that substance is what? It is having the pH 7, that is neutral solution. And if the color is coming of this kind, that is violet, indigo, blue, then it will be base. The most basic one will be violet, then less basic indigo, then minimum basic will be for blue. Similarly, on the another side, the red means what? Red means most acidic in nature. Then similarly, orange, little bit acid, less acidic compared to red, and yellow is, that is a weak acid. So yellow, orange, red, they all are for acids. Violet, indigo, blue, that all are for bases, and green is for neutral. So this is how we can identify the different acidic and basic natures of different substances or different solutions. That is all for pH here. Now we will move on to the importance of the pH in our everyday life. What is the importance? Why we are studying this pH? Why it is being called so important? So first thing, our body works in the pH range of 7 to 7.8. That is the normal pH range. Below this, if the pH falls below 7, then also problem will occur. If the pH goes more than 7.8, then also problem will occur. So this is the normal pH range. All the biological functions, all the chemical reactions in our body should go on in this normal pH range. So that is why pH is very important. This normal pH should be maintained in our body. Second thing, in agriculture it is very important. That is for the soil. Every kind of soil is having a pH. The pH variation of the soil will tell us the soil is acidic in nature or basic in nature, and based on that the different kind of crops can be grown. For example, rice grown in slightly acidic soil. Similarly, sugarcane on the other side, it will not grow in acidic soil, it needs neutral soil. Another example, citrus fruit, the vitamin C containing ones. The citrus fruits like oranges and all, they will grow in alkaline soil. So this is the variation of different crops needing different types of soil. So based on the different kind of pH level in the soil, different variations in the crop patterns can be observed. Next thing is about acid rain. Acid rain is what? Acid rain is when the acidic gases like sulfur dioxide or carbon dioxide or nitrogen dioxide, all these gases are present in the air in the form of air pollution. And when rainfall occurs, this rainfall, that is water, is mixed with these gases which are present in the atmosphere, and these gases mixed with this, what will form? In the topic of acids we have seen acidic oxide plus water give us what? That will give us acid. So acid will produce, different acids are formed. So in this acidic rain, what is actually is falling down in the form of rainfall is acidic water is falling, acid is falling. So this acid rain can be prevented by the knowledge of pH. The fourth importance of pH is regarding the diagnosis of different diseases. For the identification of different diseases, different kind of tests are performed by the doctors. So they can be blood test, it can be urine test. So in that also pH plays an important role. So that is for the diagnosis of diseases, knowledge of pH is essential. Next is point number 5 now, in digestion of food. So whenever the food is eaten in our stomach, an acid is produced naturally, that is hydrochloric acid, and it helps what? It helps in the digestion of the food, that is normal process. But in case overeating is done, food is eaten in excess, then for digestion of that extra food, what has been overeaten, extra acid will be produced, more HCl will be produced in the stomach. That will lead to acidity in the stomach, that cause different problems. So acidity can be maintained, or it can be regulated or made normal by any basic solution, that is the neutralization reaction only. Acid has to be neutralized by a basic solution. So what we are taking in that case, we are taking antacids, that are special medicines for in the case of acidity, and they contain what? They contain milk of magnesia, that is MgOH2, magnesium hydroxide. So they will do what? They will neutralize the acidic nature, or the acid will be balanced by that antacid. Now point number 6, that is in preventing tooth decay. We need to have a knowledge of the pH here also. When we are eating food, in case some food particle remain stuck in the tooth, between the teeth, then the food particle there, that will be acted upon by the bacteria that are naturally present in our mouth. The bacteria will act upon the food particles stuck in the mouth, in the teeth, and they will release acids. That process will release acids, and that acids will do what? They will do the corrosive action in the teeth. The tooth is made up of tooth enamel, that is calcium phosphate. It is one of the hardest substance in the body. It is very hard, but still, if acid is depositing all around the tooth, then what will happen? This tooth enamel will also get corroded, and it will dissolve in that acid. That will lead to tooth decay, and cavities will form. So for maintaining this, what we are doing, we are regularly using a basic substance, that is toothpaste, that is a basic substance. So that is base is applied on the teeth to neutralize the acidic nature of the acid that is formed regularly in our mouth. So that is preventing the tooth decay can be done by this method. Next one, the bee sting. The bee sting also produces acid in our body. Whenever bee stings our body, at that part of where it has bitten or it has stung, there only it will produce acid, and that acid also can be neutralized by a base. That is, we can apply any basic substance, like we can apply baking soda there, and it will give us relief. So here the topic of pH completes. So we have learned the definition of pH, how to calculate it. Then we have seen the use of universal indicator and the importance of pH in everyday life. So the topics regarding acids and bases all have been completed.